present here. So the topic of our presentation is literary text mining using web feature clustering. And so the authors are Marianna Dilai and Iryna Dilai. So basically, okay, not sure if it can, I would like to change slides, but somehow the next slide.
Maybe page up, page down, no?
Okay. Let me share it once again. I'm sorry.
Okay. Please choose maybe other window.
Okay, if it is possible to share it like this. Can you see the introduction?
Let it be like this.
Let it be this way. Okay, sorry, because I don't know why, but the slides didn't change. So the study aims to harness literary text mining techniques by testing feature clustering model capable of eliciting the prevalent thematic content and measuring the thematic and semantic affinity among the literary works. So we exemplify our research by the works of the postmodern author Margaret Atwood. Our tasks are as follows. So first, we strive to create and process a corpus of works. So we use some pre-processing techniques. Then we elaborate an efficient text analysis model that can be used for text classification predictions and test the performance of verb-based text clustering, assuming that verbs can serve as meaningful and informative text structure features. And thus we can account for the thematic patterns and topics generated by our model. Text is generally viewed as one of the most sophisticated types of data. And when it comes to literary text, it's also a very sophisticated type of data. A lot of related works can be mentioned. So first of all, literary text mining is a field at the intersection of computational linguistics, literary studies, and machine learning, and it offers possibilities for uncovering hidden linguistic patterns within literary texts. So the applications of literary text mining are as follows. First of all, we can use it to reveal genre-dependent features. It is used for topic modeling, for cataloging documents, for identifying the features of author's style, and most recently for so-called distant reading, when we use a special computer-assisted mode of reading of especially very large volume of literary works. And such kind of reading provides abstraction to the reader's researcher's detachment to viewing, processing, and interpreting the text. The very term distance reading is applied, was invented by Franco Moretti, and it is an approach which relies on computational techniques to represent the perspectives of vast collections of texts. So the topicality of our study stems from the fact that the major problems facing researchers to the need for dimensionality reduction and boosting the performance of machine learning algorithms applied to text mining. Thus, our methodology relies on the following tenets. So we strive to test feature-based clustering while selecting verbs as meaningful features, though other parts of speech can be also selected. Of course, we apply tagging, part of speech tagging using a pen tree bank. as part of pre-processing. Our corpus consists of 16 works by Margaret Atwood used as a training data set, and plus 3 more works used as a testing data set. And then the automated data processing is performed by applying Orange, a machine learning and data mining suite used for data analyzing through Python scripting. The stages which we followed are as follows. So first we apply text pre-processing, then we cluster the training data set. We visualize it by means of dendrograms. And first we implement an n-gram-based embedding. Then the results are compared to the clustering of the training data set by applying another method, a back-of-words method. The clusters are analyzed in terms of the topic affinity based on the common semantic content. Since we also mean to test predictions, so we also apply some other supervised methods, such as logistic regression classifier is applied, and then predictions for the testing data set are made based on the trained model. The same stages are repeated, selecting verbs as a meaningful feature, which is tested. We test its performance. We compare the clusters obtained by means of back-of-words methodology and by means of verb-filtered methodology, and assess their performance, calculating the RAND score. Basically, this is the workflow of the clustering process in Orange. So we can see that here we can use 2 kinds of clustering, by using document embedding and by using back-of-words. And we rely on hierarchical clustering, by the way, and on cosine distances. So the fast text embedding method, which is based on n-grams, actually resulted in the following map of words, 2D map of words of documents which represent the works. Then when we click on them, we can see actually the content of the clusters. We can see the key words which can be which are in each cluster. For example, here we can see the keywords in cluster 1. Then we apply the back-of-words clustering. Thus, we can see here all the documents, 16 documents in the training data set. And we can see all the words which appear here. Of course, we get rid of stop words. Yes, and thus we test this kind of model and also get the clusters based on back-of-words. Thus, ultimately, we receive the 2 basic clusters. So the results are pretty much consistent, because even here we can see that in the first cluster we have 2 works, so the first work which is here is The Testament by Margaret Atwood, 1 work, and the second work is its sequel, which actually means that probably the clustering was done in a good way. Yes, intuitively it means it, and the researcher from the standpoint of literary analysis can see it, that the sequel probably contains the same topics, yes, as the first book. And then we try to predict whether the remaining 3 works, which form a testing data set, would be clustered in the proper way, whether they would get in the proper clusters. So we here is the workflow for prediction. So it is the intermediary stage for prediction is the logistic regression stage, because it relies on classifiers. And also the classifiers rely on so-called nomograms. These are words which especially contribute to the classification of the words, yes. And probably it can't be seen well here, but here rather such key words as aunt, as for example, author, etc. Yes, and thus the prediction results for the unclassified text are as follows. All the three texts belong to the second cluster. And then we test the verb feature selection. We select all verbs from the back of words. We apply a special filter for that purpose and repeat the same. The resulting clustering is a little bit different. We can see that cluster 1 and cluster 2 somewhat differ, but not dramatically. And then we can also see the content, but here we can see the key verbs, not all items, but not all tokens, but only verbs, which stand out in the cluster. And we calculate the rand index, which shows the similarities and discrepancies between the clusters. So it amounts to 0.7 approximately, which is not a bad score, in fact. Then we also want to test whether we can use verbs for predictions, yes. And the result was actually very good because all the three works belong to the second cluster, just as it was in the first case, yes. So also we try to identify the items which contribute to some topics, and there are really some kind of patterns, yes, meaningful patterns, verbal patterns. For example, in the first cluster, if you go back, yes, we'll see verbs which refer to the topic of to the topics connected with female and gender-related themes. So we can see such verbs here which stand out and have especially high frequencies and serve as key verbs, such as to knit, to cry, to shop, to dress, to cook, which are related to this theme. And then there are some verbs which are related to the topic, to more social issues, such as to pay, to keep, to save, to drink, together. In the second cluster, we have more verbs which are connected with the process of creation, such as to write, to draw, to color. So all these verbs actually are indicative of some topics and themes in the novels, yes, which we have studied. Although the model still requires testing and improvement, we can see that the result is quite satisfactory, and taking into account that the lower level clusters are better classified. So we may say that the verb featuring applied by us is quite efficient. So the conclusions we draw as follows. So the applied feature engineering lies in defining, selecting and testing verbs as informative clustering features. Although it shows a good performance, it still needs training on a bigger data set. Literary text mining using verbs as special features sheds light on some linguistylistic characteristics of literary text, their prevailing topics and motives, and can be viewed as a plausible distant reading technique. Thank you for attention. If you have any questions, you're welcome.
Thank you very much. Maxim Vakulenko has a question, please.
Oh, thank you. Thank you, Iryna, for your report. My question is, as far as I understood, you hypothesize that verbs highly correlate with the style. My question is, my first question, what about other speech parameters, such as language, such as sentence structure, or other parts of speech, such as adjectives, or the use of exclamation marks, and so on? And the second question is, did you study the Ukrainian language in this sense?
Thank you for your questions. Of course, we can test also other parts of speech and other features. Basically, in in machine learning and data science, they often, in computational linguistics, they often rely on n-grams, and they say that n-grams have the highest, the best performance. Yes, not like separate parts of speech, but n-grams. I chose verbs because verbs are actually my scientific interest. Yes, linguistic scientific interest. That's why I wanted to test them, first of all. And according to the calculations, especially in fiction, every fifth word is a verb. So which means that they are quite prominent. So they are very frequently used, and they have some functional load in the style of fiction. That's why I chose verbs. But of course, we have also tried, actually, frankly speaking, to test this model on other parts of speech, and it also has a good performance. Yes, when we take nouns, adjectives, or other parts of speech. But I guess we still need to understand that, for example, in functional linguistics, we have a distinction between theme and dream. Yes, it depends on what we want to see. If we want to see the topic, the theme of our works, yes? So it's better probably to take nominal parts of speech, such as nouns, adjectives, perhaps even pronouns if they are meaningful. But if you want to find ideas, yes, so the rhyme, so new information in our texts, yes? So it's better to take verbs, because verbs contribute to new information found in the text, to what is written about the theme. Yes, so the so-called ideational metafunction, which was defined by Michael Halliday, yes, is performed by verbs, by processes, yes, by verbs mostly. That's why we focus.
Thank you. We have round table. We can continue there. We have timeline. Sorry.
And Ukrainian language will be like the prospect of future research. Yes, thank you.
Thank you.
I hope you're satisfied. Okay. Then we should go to next report. Volodymyr Riznyk, please. You already know how to share your screen, please.
Can you see?
No, still not.
Not yet.
But now?
Once again, you already know how to do this. Button share screen, green button on Zoom. You go to Zoom.
Okay.
Oh, maybe pushed not green, but red Zoom, red button. Let me wait some time. Then we have Olha Kulyna present, I see.
I'm
Yeah,
here.
you will be next, yeah. And then Tetiana Kovaliuk1, Iryna Yurchuk, Olga Gurnik. Yeah, Yurchuk.
Yeah.
Okay, okay, good. Then we have already reported 19th report. There we have window and have time to let Volodymyr Riznyk be ready. Maybe he reconnects. If not, then we will go to next report. Already 10 minutes. I'm not sure. Please, Olha Kulyna, your turn.
Yeah, okay, I'll share my screen. Let me do it. And which one? Yeah, I think because today I am presenting two papers, but I think this time it's that one. Okay. Okay. Hello, everyone. Let me present our paper, Synonymous Variation of War in the British National Corpus using Sketch Engine, a linguistic analysis. This paper was conducted by me, Olha Kulyna, and my colleague, Zoriana Rybchak. Do you see my slides changing? Has it changed?
Yes.
Yeah, good, perfect. So why we did it? So the article analyzes different ways the word war is used in the British National Corpus using Sketch Engine. The goal is to explore how war is applied in various contexts and to conduct an analysis focused on synonymous variation. One key benefit of corpus-based analysis is the ability to generalize findings across a diverse range of texts, providing a more representative understanding of language usage. Unlike traditional approaches that rely on individual examples or limited data set, the corpus linguistic enables researchers to identify patterns that may not be immediately apparent, contributing to a more comprehensive picture of how the language evolves and adapts over time. So what we did for our research, we use Sketch Engine, which is a powerful tool for analyzing language, helps examine the different ways of mining vocabulary and text. And this method provides insights into the meaning and usage of the word. So what was our hypothesis? The hypothesis of the study is that the war exhibits significant synonymy across British National Corpus, appearing in various linguistic forms and contexts that reflect the multifaceted nature of conflicts and warfare in English language. Though this analysis, the researchers expect to uncover distinctive patterns of synonymous usage, shedding light on how language shapes and reflects attitudes towards conflicts and related phenomena. So for our research, we used the British National Corpus, which contains 100 million words from various resources of written and spoken English. Particularly, we used British National Corpus XML edition for our analysis. British National Corpus works with Sketch Engine and offers complete set of tools such as word sketch, thesaurus, word, keyword, word list, n-gram, concordance, trends, and text type analysis. Our research was limited to word sketch, thesaurus, and concordance. CQL, Corpus Query Language, was used as a specific code or query language in Sketch Engine. It enables users to search for linguistic patterns and set search criteria that are beyond what the standard user interface allows. The word war appears 21,541 times and functions as a modifier. The word war modifies another word. Verbs used with the word war are obtained as an object and as a subject. Other nouns used with war with a conjunction and prepositional phrases and adjectives. We generalize a list of synonyms for war using the thesaurus feature in Sketch Engine, initially examining the top 50 results and then narrowing down to 20. These synonyms were analyzed using CQL. Using the one-click dictionary option, we identified words that do not correspond to war based on their meaning and context. So the findings of the study are illustrated in the pie chart on the screen, which breaks down 10 distinctive categories of synonyms for war based on their prevalence within the corpus analysis. Operation represent 21.8% of all recorded synonyms indicating planned military action or maneuvers with specific objectives. Attack accounts for 15.2% of synonyms referring to offensive actions aimed at causing harm or damage. Campaign represents 14.4% of synonyms indicating organized military operations with specific objectives. War represents 10.1% of synonyms reflecting large-scale armed conflicts between nations and groups. Conflicts contain for 9.9% of synonyms representing various disputes or disagreements ranging from interpersonal to social issues. The next on our list is crisis, which represents 9% of synonyms reflecting critical situations marked by instability and potential escalation. Battle, 6% of synonyms signifying engagement characterized by intense combat and strategic maneuvers. Revolution comprises 5% of synonyms denoting organized movements to overthrow established political and social system. And the last on our list is rebellion, possesses only 1.5 of synonyms indicating acts of resistance and defiance against authority. And now let's come to conclusions. In conclusion, this study enhances our understanding of corpus linguistics and provides practical insights into how war is used and represented in English texts. By exploring the different synonyms for this term, we aim to show how language adapts and reflects human experiences of war and wartime. While this allows for an analysis of big data easily, the results are rather generalized since the corpus contains text from different genres and different periods. Further research could explore genre-specific analysis, namely investigating how the representation of war varies across specific genres. Thank you very much for your attention. And if you have any question, please.
Thank you.
Yes, I have a question.
Yeah.
Thank you for your presentation, but I wonder, why do you call these words synonyms? I have just opened the Open English WordNet, the concept war, and there are only synonyms, only the following synonyms: state of war and warfare, and all of them are for different meanings. In other words, for different concepts corresponding to this. So my question is, I would like to call these words like meronyms or the holonyms or the partonyms and so on. Why do you call them synonyms?
I'll let you know. So this is our second research. The first research we presented 2 months ago with the other at the other conference, and that time we aimed at analysis of the same concept but within 3 languages, and it was named only about how it is described for the current situation in Ukraine. And this time we wanted to have a look at broader version and to mine big data. That's why we opted for British Corpus, British National Corpus. And British National Corpus incorporates creates sketch engine, and there are different tools inside which you can use. And one of them is Thesaurus, which is the implemented dictionary to search the synonyms for a particular concept of word. And we were offered more than 50, and then these 50 we narrowed to 20, and then again using the dictionaries which are embedded in the corpora, we came up to our results. So this was the procedure, and no human intervention was implemented in this process.
Okay, you answered another question, but anyway. So I have the next question. Are you planning to use Open English WordNet or Open Ukrainian WordNet for such purposes?
Could you please repeat it?
Open English WordNet and generally speaking WordNets for such a task.
British National Corpora, we use British National Corpus corpora for that. And inside this corpora, you have all the tools implemented. So we didn't use anything outside it. So it works like any other corporas.
And this corpora also allows using synsets, for example. Synset as one word, different, one meaning, but different words.
Yeah.
Okay. I put in chat links to Open English WordNet and to the Ukrainian WordNet. I think that it will be very good to use in the future.
Yeah, thank you very much for recommendation. I already copied it and I'll save it. Yeah, yes. Thank you.
I also sometimes use it here, this WordNet English, but about Ukrainian WordNet, I'm not listening.
Yeah, but this time the concern of our research was English, not Ukrainian. Yeah.
Okay. Thank you.
Yeah, thank you.
Thank you for your report. And we turn back again to Volodymyr Riznyk. Maybe he already do his report now. I see Volodymyr is present, but silent. And some problems with computer, maybe. Okay, then going to next report. It will be Tetiana Kovaliuk, Iryna Yurchuk, Olha Gurnik.
Sorry, maybe Volodymyr start his presentation.
Yes, okay. Please, Volodymyr, your microphone, please. Your microphone is not working. Maybe I can open his microphone. I only can ask to unmute. Sorry, we cannot listen. Microphone already unmuted. You can talk.
Microphone is.
Please start.
May I start?
Yes.
Thank
you are
you.
ready.
Of course. My report is vector data systems machine learning with combinatorial optimization. The intelligent symmetry and asymmetry ensembles is given by Hermann Weyl, the symmetry as wide or as narrow as you may define meaning is one idea by which man through the ages has tried to comprehend and create order, beauty, and perfection. The next slide, you can see a famous scientist, American, and with his invention of Golomb ruler. It is schematic solution of systems based on his invention, so-called Golomb ruler. And to right, you can see a cover sheet for cooperative grants program application between Lviv Polytechnic Institute and South California University in March 5, 1996. Research and applications of the combinatorial configurations for innovative device and process engineering. What is ideal Golomb rulers? Golomb ruler. The longest ideal Golomb ruler is a three-stage chain sequence. For example, 1, 3, and 2. The sums of connected elements of the ruler enumerate the set of integers. As you can see, 1, 2, 3, 4 is 1 plus 5 is 3 plus 2, and so on. Only 3 are ideal Golomb rulers, namely 1, 1.2, and 1, 3, and 2. And the next we can see ideal ring bundles. Numerical ideal ring bundles are cyclic sequences of positive integers that form perfect partitions of a finite interval 1 and s of integers. The sums of connected subsequences of the IRB enumerate the set of integers from 1 to s minus 1. As you can see, unlike ideal Golomb rulers, there are a priori an infinite of number of one and multi-dimensional ideal ring bundles. Comparative analysis of ideal Golomb rulers and ideal ring bundles sequences. Let us calculate all sums of the terms in numerical and stage chain sequences of distinct positive integers, where we require all terms in each sum to be consecutive sequence elements. The maximum such sum is the sum of all n elements as given on the equation Sn is equal to n and minus 1 divided by 2. If we regard the numerical and stage sequence as of distinct positive integers, where we require all terms in each sum to be consecutive elements of the sequence as being cyclic, so the Kn is followed by K1, we call this a ring sequence. Ring sequences is equal to n multiplied by n minus 1 plus 1. Comparing the equations 1 and 2, we can see that the number of the sums for consecutive terms in the ring topology is nearly double the number of sums in the daisy chain topology for the sum sequence of terms. Vector systems information theory, namely the concept of ideal vector bundles, can be used for optimal solution for wide classes of technological problems. Ideal vector bundles are sets of T-stage sequences of N-stage numerical subsequences of the sequences that enumerate a set of topological closed T-dimensional coordinate grid, M1, M2, and so on, MT. For example, diagram on the figure consists of three-stage sequences of two-stage subsequences placed inside another, so that the inner sequences is a two-dimensional sequences 1 0 1 2 1 1 yellow bits, while the outside one forms the rest two-dimensional vectors by summing modulo 2 and 3 of the based vectors, blue bits. The arrows point to the summing, giving locations of the all modular sums in the this ring diagram. The next table, we can see an example, the optimized two-dimensional binary code based on the two-dimensional ideal vector bundle, namely 1 0 1 1 1 2, with informative parameters as symmetry, order of symmetry 7, and n is equal 3 digit weights of the two-dimensional code. These weights are 1 0 0 1 1 1 2. On the left column, we can see vector two-dimensional, and to the right table we can see code words of each vector. 0 0 vector is 0 1 1, 0 1 is 1 1 2, and so on. The next, we can see example of optimized vector data processing system. Not coding, but processing also. Two sets of category attributes concurrently under the torus suffice coordinate grid of size 2 and 3. The first category and the second category. Okay, let us go on. The next slide. We can see the star code ensembles follow from the intelligent sets of ideal B combinatorial configuration. These codes are well appreciated for configuring the vector data systems security. For example, the star code based on the ensembles of ideal urbans, as you can see, the first and the second, given the tables for vector data system coding and processing. In general case, we can see a spatial coordinate system based on multi-dimensional vector ideal ring bundles. Each reference point in the system with t coordinates mutually corresponds to a certain set of features of a t-dimensional discrete signal, and the set of reference points corresponds one-to-one to a set of sets of signal signs. The t counting is carried out on the t-ring axis of the coordinate system according to the ordered sets of which mutually corresponds to a combination of t-dimensional binary code. A symbolic view of the annual axis of the t-dimensional spatial coordinate systems with a common point plus is given on the right. Conclusion. Combinatorial optimization of vector information technologies focuses on intelligent vector information technologies and systems security based on the ideal ring bundles concept for the development of new directions in fundamental and applied research in system engineering using the underlying theory. Vector three-dimensional star codes forms ensembles of cyclic multiplicative groups with properties, remarkable properties of the structure to rebuild. This technology allows reducing the total processing time of information flows by encoding data on lists of two or more attribute categories at the same time concurrently. Therefore, vector IRBs improve the structure of databases with minimal memory and computing resources, supporting complexes of standard libraries of programming languages. Implementation of intelligent multidimensional optimum encoding system planned in laboratory works provide learning for graduate students studying computer science and information technology at Lviv Polytechnic University. Vector data systems, machine learning with combinatory optimization focused on all technical and practical aspects of the latest research and results of international academicians, scientists, and practitioners related to intelligent information technologies and system of information security in Ukraine. And symbolic presentation of multidimensional, optimum multidimensional vector data sets under the manifold coordinate systems is given on the slide. Thank you.
Thank you very much. It's quite complicated for me, but maybe somebody understands mostly and can ask a question to the reporter. Thank you. It needs some additional time to...
I'm sorry. I am sorry
Yeah.
for the time.
Thank you.
Thank you.
Okay. Then we are going to next report. Please unshare your screen. And we are going to Iryna Yurchuk, Olga Gurnik, who will be reporter. Tetiana Kovaliuk1, Iryna Yurchuk, Olga Gurnik. Topological, знов topology. Structure of Ukrainian tongue twisters based on speech sound analysis. Absent?
We hear, but we try to share.
Okay, a moment. I will try to close.
Yeah, the previous presentation is still open.
Yeah, I closed, and now I will allow you to. No, sorry, one moment. This way. Maybe now you can.
So let I try.
Please.
Can you see my
Yes.
presentation?
Yes.
So thank you very much. First of all, I would like to thank organizers for opportunity to take a part at this workshop. Our presentation, our paper is Topological Structure of Ukrainian Tongue Twister based on speech sound analysis. First of all, what is the reason to interested in this theme? In any language, there are many texts, short texts that have special aim. So for a hard talker, we can use tongue twister for improving diction, for politician, for children with some speech problem, with the aim of speech therapy. So it's what is the main reason to consider these methods topological? The main problem for tongue twister you cannot use popular machine learning methods, because there is small data set, several hundred, and all of them there is no sounds for training neural networks or deep learning techniques. So we at the beginning we start to detection tongue twister, but we obtain the result that was not so good as we want to obtain. So the purpose of this work to study feature, we try to detect, to find the topological feature of tongue twister in as invariant for problem speech therapy. So we accumulate and try to solve what is the main reason to use tongue twister for get better our pronunciation and other speech problem. So first we have to put every Ukrainian tongue twister in some space. We in this work we use 7-dimensional space. First two coordinates, first coordinates ordinal number of speech sound in the text, and next is the ordinal number of the words, is the same as cluster where our speech sound is, and then the third is for wall speech sounds, and next for coordinates for consonant sounds with a different aim with this different aim by volume, by space of creation, methods of creation, and by hardness and softness. So there is an example of some simple, very simple, small tongue twister. Їла Марина малину. So as we can see, the first coordinate is the ordinal number, and then we use some speech sound in Ukrainian. So it's has this coordinate, but we if we consider R, we have more complicated structure of coordinates. So a bit what's about our methods, persistent homologies, and the main aim of this process is the following. We start with a cloud of points. In our works, seven-dimensional space, and then by using some parameter epsilon, we start to construct some structure. It's a simplex, and after then we start to calculate some topological invariant. We use in our work Betty numbers, and for understanding their geometrical sense, zero Betty number is a number of connected components, and the first and next is the number of dimensional structure. One dimensional is the same as circle, and then we enlarge dimension of structure which is embedded in our geometrical structures. So data set. We do it by ourselves. We use speech therapist data set, and there are 100 tongue twister, and we have to remark that there is a bit special condition that more of them are a bit short with 30 or 40 speech sounds. And it's example of changing the geometric structure of tongue twister був господар та й розгосподарився. So we change parameter epsilon, and step by step we have different structure. And last structure is circle, classical circle, and start with disjoint union finite number of disks. So first step of our algorithm, we embed our tongue twister in seven-dimensional space, and that, after that, as a good practice of machine learning, data science, we start to map it into a unit cube for and take very comfortable cloud of points. So on the right hand there is a bit small three-dimensional presentation of points, every speech sound of our tongue twister. Next step, we start to structure for our clouds. We fixed epsilon 1, epsilon 2, and so on, and start to calculate for every structure Betty numbers, and we obtain as output a number of a vector. And so what we obtain as a result of our researching, and the main result that all tongue twister in Ukrainian tongue twister hasn't a very complicated structure because of Betty number more of 2 is a 0. So for some special value of epsilon, there is cyclic structure, and this cyclic structure is stable, very stable, and there are many tongue twisters that preserve the structure of cyclic. So, and next, there is a histogram of tongue twister. We consider it as a dependence of mean of 0 Bethe numbers, connected component, and first Bethe numbers is the same as cycle in tongue twisters. So, as conclusion, we try to obtain vectorization with the aim of speech therapy, and we form cloud components. We calculate Bethe numbers and obtain that the cyclomatic structure is stable structure in this part of language in Ukraine. So the next in the future we would like to have some methodology to generate artificial tongue twister and start to use neural network or deep learning methodologies for improving detection tongue twister as a part of language. Thank you very much.
Thank you. Very interesting. When LLM start to construct tongue twisters, nothing less to us. Okay, maybe somebody have questions. Please, Maxim Vakulenko, yes.
Okay, thank you. It was an interesting approach, but anyway, I have questions. The first question, I wonder, why did you use your combination of parameters to describe consonants? Why did not you use the parameters that are given in the International Phonetic Alphabet?
So at our first work, we use alphabet and we use only letter. We use 4-dimensional space, and in this this small dimensionally space, the structure of tongue twister wasn't so amazing. We lose some information, and we see the effect when simple sentence didn't distinguish from tongue twister. We use sound.
So you didn't use the IPA, and my question is too difficult for you. Okay, I will send you a link with the explanation. If you will be interested, you can read it. But the next question is, you employ the Ukrainian texts, and the only system available in internet is the Ukrainian national standard, Ukrainian transliteration standard is DSTU 9112, which allows for one-to-one correspondence between initial and transliterated text for the task to restore the initial text. Why did not you use this national standard?
For what? For building our embedded in a space of coordinates?
I mean, you write Ukrainian text in Latin script, so you use Latinization or Romanization. The Ukrainian national standard for transliteration.
It's for example, we use not its translation only for this conference. We use Ukrainian original letter, Ukrainian alphabet, not transliteration. It's an example for our conference workshop transliteration.
Okay, so I will give you a link to this standard too. Thank you anyway.
Thank you. Yeah, then What we shall do next? We already listened report by Yurii Matseliukh, Myroslava Bublyk on previous subsection. And now he have free time. Should we shift reports upper and listen to next, or wait for right time? I'm not sure. Let we going to, okay, to next report. Olha Kulyna, Tetiana Belova, Victoria Demina, Ірина Побіженко і Тетяна Доміна, не знаю, Деміна. Хто то буде?
Hello.
A little bit louder, we cannot listen to you. Victoria Demina, yes?
Yes, I am.
Okay, yeah, we are listening. Please share your screen.
Yeah, you can see
Yes, we
the
can see.
presentation.
Please.
Mhm. Dear colleagues, good evening. My name is Victoria Demina. I present a team of authors and report on the topic ontologically support case-based reasoning for decision making in humanitarian response processes.
Okay, please. We see you.
Yeah, humanitarian aid is a type of assistance with remedies for living, which are provided free of charge to the population of areas affected by a humanitarian disaster. Humanitarian aid is characterized by its urgent nature and the necessary of conditional monitoring of the population needs. The main direction of humanitarian response are food security and livelihood, healthcare, housing and non-food product, water, sanitation, hygiene. Humanitarian response is a complex and multi-stage process where the most important criterion is the time of providing the necessary assistance. The need for humanitarian response may take place over a long period of time. In addition, there are many unplanned factors in the implementation of humanitarian project. The situation in the disaster zone can change rapidly, which lead to new requirements of the providing of assistance. In the process of decision-making in humanitarian response, the following should be taken into account. The best possible solution is selected because there is no guaranteed solution to the problem. Accumulate experience of solving similar situation is used as the main source for decision-making. Obtained solution can be used in the future with the possibility on the adaptation on new situation. The model of knowledge representation on the subject area determines the efficiency of decision-making. The specificity of humanitarian response requires simple and adaptive models that are easy to apply in rapidly changing situations. Case-based reasoning, CBR, can be used to solve this cluster of problems it has provided itself will in situation where the principle of regularity is fulfilled and the tasks that have to be solved are repeated. The knowledge accumulated by the system can be used to process new scenarios. The CBR process includes 4 main stages that form the CBR cycle. Retrieve the most appropriate case or cases on the current situation from the case base. Reuse of the retrieved case to attempt to solve the current problem. Revise in the necessary for the resulting solution following the current problem, and retain the newly made decision as part of the new case. The disadvantages of the CBR method include: does not solve fundamentally new problem, does not take into account previous decision, difficulty is choosing a criterion for extracting cases. The question areas of adapting the case base of cases, where is it not possible to extract a similar template. In this case, it is possible to combine CBR with other method precisely at the stage of cases adaptation. Traditional CBR represents knowledge in the form of parametric description of a solution and its corresponding solution. The parametric representation of a case is the most common, and processing such data requires less support and maintenance. Ontological cases are used to represent more complex relationship between subject matter concepts. An ontological representation is an explicit specification of conceptualization. It allows you to create a model using the concepts that experts use to analyze information. The adaptation of the ontologist approaches is a holistic and systematic representation of the subject area, which makes knowledge accessibility and allow for its reuse. The slides show an example of this description of an ontology attribute set. This set is divided into 3 subjects and correspond to the categories or classes is attributes: essential, territorial, and resultant. Ontology support case-based reasoning consists of 3 stages. Selecting the ontology that best suits and current situation and adopting it as the main ontology for solving the problem. Adaptation and development on the main ontology to eliminate the imperfecting of the current situation in terms of territorial, essential, and effective attributes. Enrichment of the adapted ontology with new knowledge based on existing taxonomies, thesauri and knowledge gained from previous experience using method of alignment and fusion of cases represented as ontologies. Representation of the ontology O1 on the ontology O2 means trying to find for each of the concepts in the ontology O1 a similar concept in the ontology O2. The taxonomies of the 2 ontologies can be linked through multiplicity, which is corresponding to acquirement concepts. The parameters of measure the length of the shortest path between 2 vertices corresponding to the compared concept and the general specificity of vertices are calculated taking into account the introduced multiplicity. The conceptual proximity of ontologies can be evaluated as a proximity of taxonomies. If a term exists only in the ontology and is absent in the second ontology, the term of the semantic copy corresponding to term 1 and all concepts in the second ontology are completed. A maximum is taken as the taxonomy proximity with respect to this term. This operation is done for each term in the first ontology, after which the taxonometric proximity for the two ontologies is calculated as the average of the lexicon of concepts in the first ontologies. To conduct the experiment, a classification of threats that lead to the need for a humanitarian response was carried out. In accordance with the humanitarian response plan of Ukraine for 2024, the main cluster of humanitarian assistance have been identified. For each cluster and unit classification of these types and typical responding scenarios have been identified. A fragment of the threat classification for the water sanitarian hygiene cluster is shown in the table below. Based on the classification and data from open source, 50 ontological representation of precedents were developed to reflect the relationship between emergencies and humanitarian assistance scenarios. Examples of ontologies are shown in the figure. In addition to hierarchical relationship, the ontologies contain object relationship between concepts, which allows for logical inference. Let's consider an example of the development of an ontological case that was determined to be the closest to the current situation and the first stage of CBR. Figure shows a fragment of case 01 in the process of the development case 02. In the process of its development case 01 with a new branch. The result is the case encouraged 01. The slide shows an example of the encouragement stage in the process of finding drinking water for the population. As you can see, when encouraging on the ontology, you can see you can use the found case where lexicons have partial overlap. The decision is made based on the found coefficients. In the course of experiment, we evaluated the classification quality on the initial dataset using the parametric and the ontological representation of cases. In both cases, the dataset had initially filled with 10 cases. Each subsequent case out of the 50 development cases was fit as a new situation requiring a decision, after which the cases are sutured and adapted using the appropriate CBR method. The resulting solution was compared the solution contained in the original case and its quality has assessed. As can be seen from figure, in the case of the parametric representation of cases, when the database is filled with 10 cases, the classification quality is 36%, and the graduality increases with the database replenishment and research 80-10% when the number of cases is 50. Then using the CBR expanded with ontologies, the classification quality increased for 40 to 94% with the same number of cases. That is, we can conclude that the use of ontologies in the proposed CBR increases the quality of the CBR by an average of 5%. The extension of the traditional CBR with an ontological component allow taking into account not only previous experience, but also conceptual and semantic connection between the concept of the subject area, as well as extending them with rules and logical inference. Addition states of adaptation and enrichment of ontological cases using semantic proximity measures allow obtaining an effective solution even in the face of incomplete information about the current situation. Another advantage of the method is the nice quality of classification even with a small case database. The use of adaptable method and models of knowledge representation at all levels of management will increase the efficiently and timeless of humanitarian assistance. The proposed modified CBR with an ontological component can be used in the development of decision support system for both evaluative organization and charitable foundation providing humanitarian assistance, as well as for specialization services, government and local authorities.
Thank you very much.
Thank you for attention.
Yeah, thank you. And going to questions from participants. Any questions? It's very complicated information system you presented here, intellectual system, I don't know. And I wonder how it should be implemented. I not believe that already implemented because it's too complicated. And what is about language of knowledge representation used in this system? Some RDF, resource description framework, ontology web language, any other languages for implementing. Which language you expect to use for implementing? And you mentioned a few different ontologies together, and how with alignment ontology one to another.
Thank you for the questions.
Yeah.
Method is implemented as a prototype using Python and Protege. The prototype supports the storage of parametric and ontological cases and reasoning on them.
Python and Protege.
Yeah.
Yeah, but Protege is written on Java, and exist API on Java. how it is connected with Python, and what databases. You also mentioned databases which collects some cases of what else, I don't know. Ontology connects with databases. What data are we taking from database to ontology? Ontology is only set of essences and the relation between essences. And you recognize a right case using some of the ontologies. How it is realized. Sorry, it's too many things.
Humanitarian disasters have different factors, but the
you have these factors in your ontology, yes?
Yes. For example, both and earthquake and Holicity leads the description of water simply system. In both cases, it is necessary to solve the problem of providing water to the population. The algorithm of solving this problem will be similar. Therefore, you can see, you can use previous experiments, even if the condition of the current problem are completely different.
Okay. Exists some approach in automated planning. It has name HTN, Hierarchical Task Network. It quite close to this problem, hierarchy of tasks. And ontology of HTN, Hierarchical Task Network, could be used for these purposes, because every time water or some food problems is as a task, and subtasks for solving this task would be also represented in ontology. Okay, that's it, only as comment. Maybe somebody else have questions to report. Thank you very much for your report.
Thank you very much.
Sorry, too much words. We have a few minutes before, no, only 2 minutes, but then we are going to next report. Karey, Novakivsky, Gvozdь, Yaroslav Kis, and Natalia Kara, who will be represented. I see that I will not present this work, therefore we are going to next report. Alexander Timchenko, Bogdana Havrish, Orest Hamula. I see Orest Hamula instead of Orest Hamula. Okay, please.
Yeah. Yeah, good afternoon, dear colleagues. Let me share my screen. Do you see my presentation?
Yes.
Okay.
You can try to share full screen, but maybe not.
You don't see a full screen, yeah? Because
No.
I'm sharing the full screen for myself, and unfortunately you don't see it.
Yeah, but you can try to present slides, not as editor, but as presenter. F5.
Just a second.
Only push F5 and from this place F5, F5.
I understand, yeah, but it's not working. Do you see now?
Okay, let it be.
You see now or not?
We see, but
Not full screen,
editing.
yeah.
Mhm. As editor.
Interesting, because it's full screen for me, unfortunately. Okay, sorry for issues, but let's proceed like this.
When you share your screen, you can select different windows. You select not
Yeah, yeah. Yes, and I selected these windows. Okay. Okay. So let me present the research that called semantic analysis methods usage for the implementation of system of graphic objects content analysis. The authors are Alexander Temchenko, Orest Hamula, and Bogdana Havrish. And contents are as follows. So the article considers approaches of information technology creation for searching graphic data by the content of graphic object based on their semantic analysis. First of all, it is important to note that the term semantics is used in various works in different aspects that determine its meaning. In the theory of information, which investigates general scientific methodological problem of the development of science, information and semantics are often viewed as closely related concepts. To implement semantic analysis, the concept of a semantic unit is introduced, which is compared with elements of information determined by them and serves as a hypothetical unit of information matter. Such concept replacement makes it possible to confirm to a certain extent the correctness of the known ratios that were built to describe the technical process under study. At the same time, there was a need to carry out quantitative assessment of parameters for their description. The most popular example is the technical process associated with the transmission of digital data through communication channels. In order to calculate the numerical values of information amount, appropriate expressions were discussed. The proposed ratios allowed a non-controversial interpretation and gained the greatest popularity thanks to the works of Claude Shannon. Thus, the concept of semantics and information are related and closely interconnected. The purpose of the work is to develop and research the principle of semantic analysis, implementation and the use of its capabilities in the organization of a search process based on the content of graphic objects. Let's dive into the most common method used for analyzing the content of images. Frequency special.
Sorry, you not change your slides.
You don't see my slides?
Yes, only first slide.
Do you see that I'm changing now?
Yes, now changing.
Yes.
Okay. 7-1. 6.
Yeah, okay.
5.
So, the task of automatic analysis can be framed as finding a specific function that maps a set of images into a set elements of which are images classes. The process of determining such functions should systematically proceed through the following 3 stages. First is preliminary processing, next is identification of signs, and finally classification. In the image analysis, there are mainly difficulties associated with the preprocessing and selection of features. When addressing these analysis tasks, 2 groups of tasks can be distinguished. The first one is when the information is encapsulated in the integral properties of the entire images. Such tasks are solved by analyzing the statistical properties of a set of objects that is combined simulationally in the field of vision. To efficiently compress the information in such images, it is crucial to utilize histograms displaying the distribution of parameters most patient to image decomposition. The second group is a recognition of individual objects. according to the given geometric parameters and their selection against the background of object collection. They counting, which is another method of image abbreviated description. The fundamental elements of any semantic analysis include: first is availability of interpretation system, next is rules of interpretation system usage, and then homomorphism between the rules of using the interpretation system and the rules of building and presenting the object of interpreted. And finally, semantic consistency of the description system and presentation of the graphic objects interpretation system. The essential part of the interpretation system are the following components: semantic dictionary of the graphics object system, semantic environment, a system of environment rules which is formally recorded in the forms. For the full operation of the system, it is necessary to investigate the possibility of creating a system for evaluating the search and engine quality based on the use of semantic analysis. In this case, the task of creating and searching search result evaluation model for certain system areas. To create them, you can use the following approaches that make it possible to solve the problem of determining the search evaluating in graphic objects at the semantic level. So it includes view of the analysis of the reduction degree in the effectiveness of the system functioning, system load measures, and strategic significance of the object and the search result. The structure of the dictionary can be formally represented in the form of some hierarchical tree, which can be analytically represented as follows. To build an image model and its semantic description, it is necessary to use the alphabet of conventional designations to describe graphic primitives. To do this, it is necessary to highlight their main types that can be used in the image, while the advantage of their use is that the image model built on their basis is flexible, does not depend on scaling and positioning. In addition, such a model does not depend on the color of the primitive execution. Let's consider the proposal model of presentation of a conditional alphabet or graphic primitives. First, let's build a dictionary of graphic primitives. For this, it is necessary to solve the problem of what graphic primitives to choose for the dictionary. Since the array of graphic data contains more graphic objects per seed or created with the help of thematic graphic system, it is necessary to add those primitives used by graphic system to the dictionary. Since the most popular graphic system are Adobe Photoshop, Xara Design, CorelDRAW, and 3D Max software complexes, the main graphics primitives used by these graphic systems were selected for the dictionary. Graphs primitives describing open contours include line and curves, and graphical primitives describing closed contours include a circle or fuzzy circle, triangle or fuzzy triangle, quadrangle or fuzzy quadrangle, and polygon or fuzzy polygon. Having selected the graphic primitives as elements, each of them, depending on the shape, can be assigned a value and get their semantic description. For example, after expanding the include color, fill, and line color attributes, the dictionary description word has the following form, as you can see on the slide. So on this slide, you can see determination of the semantic significance of the elements, which include beginning, grouping of graphic primitives and their counting, determination of graphic primitives per semantic significance, recalculating of graphic primitives by number and groups they ranking, determination of graphic primitives significant, and finally the end. So, graphic objects in their sense are most fully characterized by words of natural language. Therefore, it is advisable to describe them based on methods of formal grammars and semantic features. To determine this, the semantic significance of graphic objects and their fragments, it is necessary to build a semantic dictionary from the subject area, which would include the main features of graphic objects, their attributes and hierarchy. So in the subject area of the attributes of graphic objects, their completeness, semantic significance, and consistency should be determined, which will reduce the search time and improve its quality. The rules for forming a set of dictionary elements are based on the rules defined by the content and on the rules of semantic admissibility. The rules of semantic admissibility are the result of the interpretation accepted in the subject area. In the case of subject area of interpretation, which are artificial and created by man, such prerequisites are quite few, and one or another semantic significance is in many cases is based on generally accepted and accepted agreements. The suggested inference rules for the semantic analysis of graphic objects utilize formal grammars to ensure the semantic dictionary consistency and completeness. Thank you for your information and attention. Maybe you have some question.
Thank you. Thank you. Maybe somebody present have a question, because I have one. Maybe I missed any example of such graphical primitives and semantics. Any images on your presentation?
No, we don't include it to our presentation. Yeah.
I have one good example. Do you know what is a smile? Yes, we using graphical primitive smiles. Which smile represent gratitude? You can choose any smile that represent gratitude. You have chat here, and you can check, but no direct smile for gratitude. Love, some angry, strange, different smiles, but no one really. And it's semantics of graphical primitives. You can have set of examples and semantics directly.
Yeah, I see. But this method, in general, mostly we use in the cartography when we have the object which we can choose by the line or curves or some fuzzy circle or etc.
Yeah, understand. Okay. Thank you. Maybe
thank you for
somebody else have a question. No? Thank you. Maybe let me turn back to previous report. I forgot that we have pre-recorded video, and I can, instead of this one, we start number 21, if you agree. And order will be turned back. I will share my screen and start presenting. One moment. I forgot about this possibility. What it will be. Natalia Kara, silent. Can you listen anything?
So globally,
Yes, we hear this
the topic
presentation.
of our article is the application of the analytical hierarchy process to evaluate hype AI technologies. So globally, there is an explosive interest in the growing impact of AI. The emergence of new AI technologies affects individual consumers and companies, as well as countries in general. Today, AI technologies have become a driving force of innovation, and therefore companies are forced to invest and implement new AI technologies to remain competitive. The development and active use of AI technologies allow organizations to realize potential opportunities that can become objects for improvement and implementation in their activities and ensure their success in a dynamic business environment. The relevance of the problem is confirmed by the fact that the world is witnessing rapid growth in AI spending and transformation of IT services and the convergence of various AI technologies. Well, according to the data of well-known analytical agencies, the average annual growth of the global AI market in 2023 is within 38%, as you can see in Table 1. AI encompasses a wide range of methods and disciplines, including vision, perception, language and dialogue, decision-making and planning, problem-solving, robotics, and other areas of application where self-learning is possible. AI is optimally considered as a set of technologies and methods used to supplement traditional human qualities, such as intelligence, analytical, and other abilities. The result of research made it possible to distinguish the following main types of AI. There are artificial narrow intelligence is aimed at very good performance of a certain task, for example, based on natural language processing, Google Assistant, Google Translate, Siri, Cortana. Artificial general intelligence, which represents the behavior of the human specialist, and artificial super intelligence is a super intelligence that can be applied to solve any problem. By 2025, 75% of customer interactions will consist of AI context. Already now, analytical robots calculate a business development plan for the next 10 years in a matter of seconds, and chatbots solve typical customer problems at any time of the day. In 1995, the consulting company Gartner proposed the term hype cycle for planning, which became the name for the maturity curve of technologies. Gaza presents research materials in annual analytical report, which show about 30 new technologies that can greatly affect consumers, businesses, society, and people over the next from 5 to 10 years. The consulting company Gartner considers hype technologies to be revolutionary technologies whose viability and competitive advantage have not been proven. The company's analysts are involved in the research, sifting through thousands of unique technologies that, in their opinion, will be manifest themselves within 5 to 10 years and will have a strong impact on society and business. Well, the schedule is divided into 5 stages, which are shown in Table 2. Now you can see table 2. The stage 1 is innovation trigger, stage 2 peak of inflated expectation, stage 3 a throw of disillusionment, stage 4 slope of enlightenment, and 5 plot of productivity. The hype cycle methodology helps professionals evaluate the potential opportunities of new technologies for business. The growing attention to the development of AI is confirmed by Gartner's annual presentation of the hype analysis of AI technology starting in 2019. The summarized results of Gartner's analysis of hype cycles for artificial intelligence from 2016 to 2023 by development stages are shown in the next table, table 3. Stage 1 is innovation trigger. Here we can see stage 2, peak of inflated expectation. Stage 3, throw of disillusionment. Stage 4, slope of enlightenment. And stage 5, plot of productivity. To evaluate the implementation of hype AI technologies, it is advisable to use the analytic hierarchy process, maximum convolution based on the theory of fuzzy large quantities, and the method of analytical networks. All three methods are based on the formations of matrix and pairwise comparisons of alternatives and criteria using the scale developed by Sati. The research of the problem made it possible to form the stages of applying the analytical hierarchy process to ensure the selection of promising hype AI technologies for the organization. In the first stage, the authors will present a hierarchical decision-making structure regarding the choice of hype AI technologies for the company. And for conclusion, a strategy for analyzing projects of the implementation of hype AI technologies and the most efficient means to ensure the effective development of domestic companies is elaborated. In general, the following provisions are disclosed in the work. First, the average annual growth of world investments in the AI field is more than 25%. AI technologies are implemented in an increasingly wide range of business processes, resulting in the formation of hype technologies. The progress in the AI industry is researched by many international companies, in particular Gartner. The consulting company Gartner from 2019 to 2023 prepares annual reports in the form of hype cycles for artificial intelligence, which shows the high dynamics of changes. The innovating strategies of the development of domestic companies taking into account progress in the AI industry is developed in conditions of high uncertainty. The task of the optimal development of domestic companies can be reduced to the problem of fuzzy logic, for the solution of which a modified method of the analytic hierarchy process can be used. This method of determining the feasibility of project of implementing hype AI technologies can be perceived as a primary assessment. It allows for assessing the rationality of the company's measures as a whole, finding out according to which parameters it is necessary to carry out active innovations. Next, more precise economic, technological, and marketing justifications for specific innovating measures are needed, as well as the calculation of their cost, yield, profitability, and resource availability. Thank you very much.
Thank you for your attention. Please, dear Maxim Vakulenko, have a question. I'm not sure I'm ready to answer, but please.
Okay, thank you. It was interesting to listen. But I have a question. What is your definition of artificial intelligence?
Definition of artificial intelligence. Subject, person with possible to make decision, rational decision, taking into account knowledge base. Of
Thank you.
knowledge base. Yeah.
Oh, thank you.
Okay. And we are going to next report. Next is Zoriana Rybchak, Olha Kulyna, Myroslava Bublyk. I see. Olha
Yeah, we
Kulyna.
are here.
Right.
Yeah, at least I am here. Unfortunately, the other my colleagues couldn't attend the meeting, but I will present it.
Okay. Live speech is much better than any recorded videos.
Yeah, of course. Yeah, so can you see my screen?
Not yet.
Not yet. So why is that? Okay, I'll try one more time.
We have time.
Yeah.
But it's your desktop. Not...
Yeah, I understand. So it means that my presentation was closed, and now I have to go to my file, and that is 32. And here we go. Yeah, and now is it better?
Yes, very good.
Okay, and if I start changing slides, it's also okay.
Yes.
Oh, perfect. So, hello everyone. I would like to present our paper, but I also would like just a minute because I would like to present our paper, An Intelligent System for Speech Analysis and Control Using Customized Criteria, conducted by Zoriana Rybchak, Myroslava Bublyk, and me. Yeah, but now I cannot move the slides. Yeah, so now it's okay. Is it the second one? Yeah. So the research focuses on the Ukrainian language as the medium of communication and a vital part of Ukraine's cultural heritage. Specific topics of investigation encompasses grammatical and lexical variation across regions, language proficiency among Ukrainians, and the cultural and educational impact of linguistic development. To enhance the implementation of our language analysis and control intelligence systems based on user-defined criteria, we employed a selection of tools including Visual Studio Code. This was chosen as the primary development environment due to its cross-platform compatibility, extensibility, integrated terminal, version control integration, and customability. A versatile and widely popular programming language, Python, was chosen for its simplicity, readability, and intensive library ecosystem. It's ideal for language analysis and control system due to its clarity, vast library support, compatibility across platforms, active community, and integration with advanced technologies like machine learning. SQLite is selected for its self-contained and lightweight nature and serves as a database for user data storage. WASC model and automatic speech recognition library is integrated for speech-to-text conversion, real-time speech analysis, and word recognition within the system. Its deep learning capabilities enable accurate transcriptions. Excel was used for storing user speech data due to its ease of use, compatibility, and built-in functionalities for data manipulation and analysis. Future consideration may involve transitioning to relational databases, cloud storage platforms, or specialized data analysis tools for enhanced productivity and scalability. Cloud platforms are used for data storage and analysis, and in this case, it was Google Sheets or Microsoft OneDrive. They offer real-time collaboration and remote access to data, which can be beneficial for distributed teams and projects. And specialized software tools for data analysis like R or Python with pandas provide advanced capabilities for data processing, analysis, and visualization. This was a crucial step in creating and designing a system for several reasons. The first reason is clarity and structure. Helps to break down a complex project into smaller manageable parts, facilitating a better understanding of tasks and related requirements, and this creates a clear structure for the project. The next advantage is priority settings. Prioritize for different tasks and resources can be established, enable efficient allocation of attention and resources regarding system development. Communication and coordination as a common basis for discussion and coordinating among team members, facilitating the exchange of ideas and mutual understanding among project participants. Progress tracking can be used to track project progress at different development stages, allowing the team to monitor the achievement of individual sub-goal and make necessary planning adjustment if necessary. And the last one, risk and opportunity assessment, analyzes the goal tree and helps identifying potential risks and opportunities that may arise during project implementation. The software is developed using the Python programming language and includes the following modules: user authentication and registration module, audio recognition and analysis module, live speech analysis module, word list correction module, audio file playback module, and data analysis creation and display module. The registration process involves the user creating a profile. The register function sets up speech recognition using as a recognizer and connects to SQLite database. The user provides a login name, and if it is unique, they proceed to set up security questions and a password. The system, recognizing the spoken password, stores its security and records the user's details, such as username, password, security question, and status. It also creates a folder for the user's recording and an Excel file for text and words Z or that, and modifies the user or successful registration. If the password isn't recognized, the user can try again. After finishing registration, the user is taken back to the login screen. A new speech recognition tool is set up, allowing 3 attempts for authorization. The system then sets up the current pass and connects to the SQLite database. The user is asked to input their username. The program fetches the user's data from the database based on the provided username. If the user exists in the database, the system checks its status. If the user isn't blocked, they are prompted to speak their password. The system uses speech recognition to convert the audio to text via the Google Speech Recognition API. If the recognized password matches the stored one, the user is authenticated and their username is returned. If not, attempts decreases and the user is informed of an incorrect password. If the user isn't in the database, attempt decreases and the user is informed accordingly. The audio play and analysis model is a versatile tool designed to facilitate the playback of audio files while providing menu-based navigation for user convenience. Here is the breakdown of its key features. Pygame integration utilizes a popular Python library for audio playback. Pygame offers robust functionality for handling various aspects of multimedia, making it an excellent choice for this purpose. Nested loop structure employs to facilitate user interaction. It is a powerful programming conduct that allows for flexible and intuitive menu navigation, ensuring smooth user experience. An interface mock-up is provided to illustrate the available audio playback option. This mock-up likely includes elements such as play, pause, stop, volume control. So what are the potential areas for improvements? As potential areas for improvements in future, we consider a comprehensive speech analysis and control system, integration of various Python libraries, word clouds, implementation of word clouds and sentiment analysis, and as well as illustration. And also, as at the beginning, I mentioned that currently it works with the Ukrainian language, but also another 50 languages may be implemented. And now let's move to conclusion. An intelligent speech analysis and monitoring system tailored for Ukrainian language usage has been developed. It effectively addresses language deficiencies, provides tailored solutions, and offers valuable support for improving language proficiency and promoting Ukrainian language users. Thank you very much for listening.
Thank you. Have you questions from?
I have a question.
Please.
Thank you for your report. My question is, did you use the libraries as is, or did you change them? Did you adapt them to the purposes of your research?
Yeah, to be honest, the functional part of this program was implemented by Leslav and Zoriana, not by me, and they could have provided the extent answer to your question, but unfortunately they couldn't be present today.
Okay, thank you.
Okay, it seems to me my question also will be not directed to you. Then thank you very much for your report. And
yes, thank you very much.
Thank you. And we have next in plan Mykola Paseka, Yulia Romanisha, Natalia Paseka, Tetiana Nestorenko, Victoria Bandura, Myroslava Bublyk. Anybody present? Because if not present, and we have not pre-recorded video of presentation, but we have a presentation missed number 14, and we can back to 14 instead of this 24, 24th report. And let me show you this video presentation. Moment. I will share my screen, and please.
Good afternoon, dear colleague. The theme of our article is Modern Trends of Communication in Higher Education, Problem and Prospects. In the modern condition of globalization, informatization, and the rapid development of technologies, scientific communication becomes a key component of the successful activity of a higher education institution of any form of ownership of scientific team. Change in the modern world determine both of the forms and means of scientific communication. Traditional methods such as face-to-face meetings, publication, conference, and correspondence remain relevant, but along with them new practices based on information and communication technologies are emerging. Online learning platforms, social networks, and other digital tools open up new opportunities for the exchange of ideas and collaboration between scientists around the world. They help increase the availability of scientific information and increase its impact on society. The main goal of this study is the theoretical justification and development of practical recommendation for the formation of an effective communication strategy for higher educational institution. In particular, the study of this topic involves the use of an integrated approach to the transfer of information to potential users of educational services through online learning platforms, official websites, and university corporate mail, messenger, and social networks. This study focuses on the need to pay attention to various aspects of communication process in the university environment, including internal and external communication, interaction with students, teachers, administrative staff, as well as work with the public and the development of an online presence. It is important to note that the study aims not only at theoretical conceptualization, but also at the development of practical tools and recommendations that will help higher education institutions improve their communication strategy and increase the effectiveness of interaction with the audience. To conduct a study of the communication between university and participants in the educational process, the authors recommended using a methodology that involves the selection of communication tool depending on the goals that the university sets for communication, as well as depending on the category of stakeholders with whom communication is planned. The authors recommended highlighting 3 goals that the university sets for itself and communication with participants in the educational process. As the choice of the communication channel depends on the purpose of the university's communication with stakeholders, which allows you to distinguish the following this purpose. First, informative goals to provide comprehensive information on organization issues, education process, educational projects, class schedule, admission condition, list of specialties. Education goals to use the use of modern information and communication technology directly during the educational process, learning, online educational platforms, corporate mail, various services. And imagine goal formation of a positive and successful brand of university, positive business reputation, and successful imaging, recognition and popularity of university in the market of educational service. On the figure 1, you can see the system of communication tools of university with stakeholders depending on the purpose of communication. As a study of the current state of the communication policy of university in the world and in Ukraine requires the identification of trends and the main direction of the development of information process. This requires focusing attention on the interests of persons, the purpose of the communication policy of the university and the tools for communication with the surrounding environment. It is extremely important for university to establish an effective communication process between all stakeholders, interested parties of the education process, which includes the following groups. First, students studying directly at university, teacher, employees of university who directly carry out teaching, educational and scientific activities, applicants, potential university entrants who are looking for a future profession and educational institution. partners and other university cooperating in science, educational, research or technical activities, employers, enterprise and organizations searching for ready specialists among university students, state authorities and local self-government that directly or indirectly influence and regulate the activities of the university in educational and scientific activities, public and charitable organizations that carry out various social activities and projects. And in table 1, you can see the number of users of online learning platform in the world in millions users. As you can see from table 1, the online learning platform Microsoft Teams had only 8 million users worldwide in 2018 and 300 million users in 2023. In table 2, you can see number of messenger users in the world in millions. The most popular messenger is WhatsApp. In 2023 was WhatsApp users 2,040 million users. WhatsApp has been growing steadily since 2018, and where it had 105 million users. In second place, the Skype messengers and other. In table 3, you can see the most popular social network in the world remains Facebook with 3,050 million users in the world, while in 2018 the number of users of this network was only 2,320 million users. All companies, government institutes, charities, famous celebrities have page on this social network. And on table 4, we recommended social networks and messenger for university to communicate with stakeholder interested parties. For example, for the group of stakeholder teachers and partners and other university, it recommended to use social network LinkedIn, Facebook, YouTube, and Messenger, Viber, WhatsApp, Facebook, Messenger. For the group of stakeholders, state authorities and local government of the university, it is advisable to use social network Facebook, LinkedIn, YouTube, and Messenger, Facebook, Messenger, Viber, WhatsApp. In table 5, we recommended function of the university communication system for communication with stakeholders. The use and strengthening of the recommended function of the communication system will allow to strengthen the competitive advantages of university to form a recognizable brand of the educational institution, to improve the business image, to increase the effectiveness of the educational and training process, to use all the advantages of modern information technologies. In figure 2, you can see the trend of changing the number of users of online learning platform in the world. And in figure 3, you can see the trend line of change the number of users of education online platform, taking into account the education of the trend line and values of the correlation coefficients, which is close to 1. It is possible to predict the number of users in near future. Thus, in 2024, the forecast value of the number of user education online platform will be 585 million users, and in 2025, 676 million users. In figure 4, you can see changes in the number of messaging users on the world during period, and in figure 5, you can see changes in the number of messenger users. The forecast value of the number of messenger users in 2024 and 2025 will be 8,000 and 8,576 million users respectively. In figure 6, you can see change the number of users of social networks, and in figure 7, you can see the trend line of change in the number of users of social networks. The forecast value of the number of social networks users in 2024 will be 20,300 million users, and in 2025 is 30,000 million users. In the modern condition of the development of the economic and society, the role of information technology and communication process is increasingly growing. The growing role of information in society is felt very significantly. The use of special application and service allow shopping, training, and custom service without leaving home. The development of social networks, for example, Facebook, Instagram, LinkedIn, YouTube, X, TikTok, Messenger, Facebook Messenger, WhatsApp, Viber, Telegram, Snapchat, Discord, Signal, Skype, iMessage, MoDaST, Google Chat, and online platforms such Microsoft Teams, Coursera, Udemy, Teachable, Skillshare, Moodle is accompanied by change. As the developers of this application service and new function and tools, this allow both users and university to improve the communication process, exchange information, conduct online classes, perform various cognitive tasks. It is not an expectation that new social networks, messenger, and online platforms for learning will be created and existing ones will lose popularity. It is predicted that the number of users of social network, messenger, and online platforms for learning will increase in the world. In particular, ordinary user can be have account in several network and messenger at once, or have several accounts in social. Successful development of educational institution, including university, requires effective management and use of all opportunity of the external environment. The information sphere provides many opportunities for university and students to develop. Accordingly, an effectively established communication system at the university with stakeholders should be a management priority. The modern development of the economic and society is characterized by the growing role of information technology. The increase in the number of users of social networks and messaging, the creation of new online platforms for learning allows the university to be flexible, conduct distance learning, better inform the students and partners and place education materials. 6 groups of stakeholders in the process of formation of the communication system have been identified for university: students, teachers, applicants, partners in other higher education institutes, employees.
Sorry, let me stop this presentation because it's reading text is not interesting, it seems to me. Therefore, we even cannot ask reporters any question and discuss their results. And it's like in so-called see like this, done, do not like this. We are going to last 2 reports. And I see Andriy Bosak is present, and maybe somebody else.
Here.
Yeah, you have possibility to share your screen, and you have time to present your report.
So, share my screen.
Previous report was bad impression.
You can see my slides?
Yes,
my presentation?
yes, very good.
Yeah, okay, thank you. Good dear colleagues, for your attention, we present a report on the topic peculiarities of matching text and sound components in the Ukrainian language system development. The date various approaches have been tested to recognize the words of fused speech. In the first case, which the global approach, the word to be recognized is compared with every word in the dictionary. When comparing, as a rule, the spectral representation of each word is used. Among various methods of this type, the dynamic programming method gave satisfactory results. In the second case, with the analytical approach, each word or group of words is first segmented into smaller units. This allows you to perform recognition at the syllable or the phoneme level and store in memory the parameters duration, energy, etc. associated with the event. The segmentation can be based on finding walls, which are often located near the maximum of the integrated energy of the spectrum. In view of the above information, an urgent task is to develop a system for matching the text and audio components of the Ukrainian language content, which will provide means of effective recognition and reproduction of content in Ukrainian language fusion broadcasting. Next, the problem of automatic speech recognition can be solved step by step. At the first stage, the task of recognition consists in the external search for characteristics and only superficially characterized classes of acoustic events. For the second stage, the generalized classes of acoustic, the generalized of external criteria for the classification of internally undetected classes is crucial, which makes it possible to predict the characteristics of an unknown signal. In automatic speech recognition, firstly, it's necessary to find out whether the signal is phonetic speech. Okay, next slide, maybe you can see. Text there. Next, the purpose of the study is to create a system that can be used to align the Ukrainian text to its audio reproduction. The project will serve as a part of creating a system Ukrainian language synthesis and recognition of Ukrainian speech. Sorry. To achieve the goal, the following tasks must be solved. Analyze the existing approaches, methods, and software tools used in the field of Ukrainian language recognition. Identify the main tasks that arise in this case. Analyze the methods and algorithms of sign language recognition that can be adapted during system development. Development implement a system prototype. And the result of the study solved the actual scientific and practical task of harmonizing the text and sound components of Ukrainian language content, which consist in providing means for effective recognition and reproduction of words in Ukrainian language fusion speech. Synchronization of the audio stream and phoneme units using the GMM or Gaussian mixture models. Algorithm is used in speech recognition tasks. The basic idea is to build a model of the audio stream that can be compared with vectors of phonemic features to determine the correspondence between them. The GMM algorithm uses statistical methods to model the distribution and phonemic distribution of data in the feature space. In the context of audio stream synchronization and phoneme units, GMM can be used to model various acoustic characteristics of phonemes, such as frequency, amplitude, spectral shape, etc. When the GMM algorithm is trained on a large set of audio data, it became able to determine the probability of each phoneme for each part of the audio stream. With the help of these possibilities, it's possible to determine the moments of time when phonemes appear in the input audio stream. When using a mixed Gaussian distribution, the model of the mixed distribution is initialized with arbitrary values of the parameters, and then iterations are carried out according to the two steps described as this slide. The sequence of actions of matching the text and audio components of the Ukrainian language content was carried out using the algebra of algorithms. And the first stage of the implementation of the algebra algorithms is the description of unit terms and the synthesis of sequences, which is given below. We format unit terms like first unit term is IT is unit term of entering editing text content, and next unit term is a unit term of analysis of the text for the correctness of the specified characteristics. Next task was unit term of creating a description. Okay, and after this unit terms, we can eliminate which one used for some, maybe for other possibilities on this algorithm. So first elimination is a unit term of load reading audio component, and other unit terms you can see on this slide, but we have two unit terms like U1 or U2. It's a checking of a value has been entered for analysis, and U2 is checking the correctness of the result. As a result of the use of the apparatus of the algorithms, the following sequences and eliminations were synthesized. The next stage is the substitution of the corresponding sequences in the elimination, and as a result of using the properties of the algorithms, we subtract the common unit terms by the sign of the elimination operation and obtain the following formula of the algorithms. The developed system is presented as desktop application. The application is created in the environment of the Windows operating system. To carry out this work, the project was divided into two parts: work with the text and work with sound. Working with the text included the following tasks: reading words, applying the rules of assimilation to them, creating a basic transcription, and considering the effects of sound on each other. Work with audio included splitting the wave into frequencies, searching for sound parameters, and synchronizing transcription with with audio playback. When performing the last task, the GMM Gaussian mystery model algorithm was used, which helped to achieve high-quality results. During prototype testing, different texts were used and read by different voices. The system was configured for fast learning and adapted to different timbres of voices. The requirements for audio reading is absence of noise and moderate pace. We will illustrate the operation of the system and display the results of three main stages: creating a transcription, searching for sound characteristics to hold the audio track, and synchronizing test and the audio. As a contrast example, a fragment of the text was used for text redact прийшли в лісну пущавину. Following those tracks, they went into the first thicket. First, let us transcribe the fragment. You can see this on figure that you can see on figure 1. Next, the audio reading on this fragment is carried out. After creating the transcription, the wave frequencies are calculated. In figure 3, it's noticeable that vowel sounds have a large amplitude of low frequencies, and consonant sounds such as T have a moderately high frequency distribution up to 20 kilohertz. Using the GMM Gaussian mixture model algorithm and predefined phonetic unit characteristic, the text is synchronized with the incoming audio stream. Figure 4 shows the graphical results. As it can be noted that the created prototype of the software system successfully compared the text and sound components of the fragment по text redact. And as a conclusion, as a result of the conducted research, existing methods and knowledge systems that provide tools for recognizing the Ukrainian language and describe approaches and methods of synchronizing text and audio information have been analyzed. The stages the stages in software tools for automatic speech recognition were analyzed, which made it possible to identify the features of existing approaches. To present the main aspects of the studied subject area, the classification of sound in the Ukrainian language was considered, and the features of the detection and information were given. The next stage were determination of the spectral analysis study and its confluence of the recognition process, the stage of the audio stream synchronization and phoneme unit using the general that we described. The main idea was to build a model of the audio stream that can be compared with vectors of phonetic features or to determine specified process is performing define the correspondence between them. And the mathematical description of the specific process performed using algebra algorithms an applied software system has been developed that implements text and audio information synchronization, and at the current moment, the software solution works in form of a prototype, and further research will be directed to testing and improving the system, of course, this is in prototype mode, eliminating conflicts and expanding functionality in accordance with the specified requirements. Okay, thank you. Attention, sorry for noise.
Please.
Yes.
These questions. Yeah. Thank you for your question.
Okay.
Maxim Akulenko, you have a word.
Thank you. You have two questions from a phonetician. First, I was surprised by a transcription you used. Why not using the International Phonetic Alphabet for phonetic transcription? This is the first. And the second is, what is your algorithm to find a transcription for a given segment?
Thank you for the question. Actually, I'm only presenter. Okay, for technical part of my work is actually can be answered by my co-author. I just presenter and use and approach a mathematical mathematical algorithm by algebra algorithms. Okay, so for this maybe some deep and extended answer I cannot tell you about this. This question maybe can answer my co-author, but he's not present. Sorry.
Okay, thank you for your honesty. So you need more information from the phonetical side. So I will give you a link to some articles. Okay.
Okay, it's interesting. Yeah, thank you.
From my side, your presentation is very what it will be only reading the text on the slides. Text should be removed. Only pictures,
I understand.
illustration, not text. I cannot see these slides with even filled by letters. It's
okay. I understand. Thank you.
Presentable. Okay.
Yeah. And for next fireworks, we
you can read. Yeah, but not show us this text because it's not.
Yeah.
present.
Thank you. Thank you.
And you have present next.
Yeah.
Report. It will be last report for today.
Okay, thank you.
For the next, you also will be only present.
Yes. I just started. Yes.
Understand, but okay.
Okay, let me share the screen. And I think about text on my slides is about this presentation too. But on next works, we will be remove text and Let me share my screen here. Yes, okay. You can see my presentation now.
You can see.
Good day, Ihor Matviy, again. For your attention, we present a report on the topic peculiarities of a symbol classification and recognition of expression structures system development. Again, I'm not reading all from the slide. Just part of text, maybe some main parts. Computer vision is an activity in which statistical methods are used to obtain data and models, but using geometry, physics, and learning theory. Computer vision, is used quite widely, both in all fields. For example, mobile robot control, military application, industrial surveillance, and the new ones, human-computer interaction, image retrieval in libraries, medical image analysis, and realistic rendering of simulated scenes in computer graphics. Actually, other parts of computer vision you can see on the slide, and therefore considering the maintained features, an urgent task is analyzing symbol classification in known system and recognition of expression structures for the development of software tool for solving the given task. The problem created is not new, and therefore there are many studies related to it, and we will analyze the most famous scientific works. Main works you can see on the slide, so I think I can go on the next. The purpose of this research is develop a pattern recognition system, or rather a mathematical expression recognition system based on machine learning methods, where symbol classification and structure analysis are separate tasks. To conduct the research, we provide means for classifying symbols and determining the structure of expression, including mathematical ones. To achieve the goal, the following task must be solved: to analyze the existing approaches and methods used in the process of symbol classification and recognition of the structure expressions. The results of the study solve the actual scientific and practical task of analyzing the structure of an expression and classifying symbols using a small amount of knowledge about the syntax of mathematical expression. Mathematical expression recognition is a task which in image processing mathematical expression is interpreted by a computer, so that it can be stored, processed, and reused. Expression recognition consists of two stages. These two stages you can see on the slide. Symbol recognition and pattern recognition. Next, character recognition. A character recognition task is a prototype by which each character is recognized and classified. This is not an easy task due to the enormous number of characters. Given there is no dictionary of words like for text recognition. The same symbol can appear in different contexts, and it's sometimes important to distinguish between the example of the summation symbol and the Greek letter. Same symbol, but another meaning. Some different symbols have the same shape, for example, small p and big uppercase P. Recognizing them correctly it's not an easy task. Even more problems arise when dealing with the handwritten expressions, such as the Q problem. Quantum mechanics, for example, define a new user for symbols smaller or bigger here. Actually, you can see this maybe information about this on the main part of the paper, but on this slide you can see two pictures that showing a hypothesis from left context classification symbols, right? Character identification is not required for the structure recognition. When we analyze different symbols separately, we can see different special properties. For example, the relative position of the subscript as seen in figure 3 will not be locally the same with the symbol B or Q. However, at the global level, all subscripts must be written in one line. At the same time, the input format is an image of a handwritten mathematical expression. Tables 1 and 2 show the character classes and relations used respectively. The next stage of the research was a system design according to the object approach and the UML language. Class diagram is a structure diagram type of the UML used to visualize the structure of classes and their relationships in a software system. That class diagram of the designed system is presented in figure 4. A symbol class objects of this class are representation of symbols. They contain information about the symbol itself out of context. A symbol class object is a symbol classification. And other classes, you can see information about it on paper. The next stage was the creation of functional model using the algebra algorithms again. The first stage of the implementation of the algebra algorithms is a description of unit terms and synthesis of sequences, which is given below. Format unit terms. Yes, first unit term SI in terms of capturing the input image. Next is the unit term of image preprocessing. Next stage unit term of structure analysis and to the end. Yeah. As a result of using properties of our algorithms, we subtract common unit terms by the sign elimination operation, obtain the following formula of the other algorithms. And as a result, on figure 5 is show the evolution of the main base structure, the stack of last characters. Each time a symbol is parent, the created base structure is added to the last symbol stack. This stack will contain baseline structure object rather than the context object to simplify updating the entire structure during the recognition process. The system was tested with 1, 2, 5, and 7, and 10 iterations. The result was that 440 out of 570 characters were successfully classified. This means that average the symbol is well classified, or the actual class is considered the second most likely. And the accuracy is given in table 3. And as a result of the research of these methods and approaches used in the classified symbols and determining the structure of expression when analyzed, which made it possible to identify the peculiarities of the application and outline the range of problems that arise. The iterative algorithm was developed to use the mutual constraints between the structure and the type of symbols. One pass algorithm was implemented, which includes search with returns, which ensures fast recognition of the expression structure, and its representation was carried out using the algebra algorithms, which you can see on the previous slides. The next stage was the design of the software system using the object approach and the display of the created diagram in accordance with the UML language. An applied software system was developed that implements simple classification, expression, structure recognition. With the help of the developer system, it's possible to recognize mathematical expressions by classifying symbols and analyzing structure expression. At the current moment, the software is the solution works in form of prototype, and future research will be directed to testing and improving them. Improving the system, of course, is prototype mode, and eliminating conflicts and expanding functionality, plus not only mathematical symbols. And again, it's in prototype mode, so not all symbols are classified. And actually, I think we can go further and add more tasks to the system. From me, it's all. Thank you for your attention. Maybe you have some questions.
Thank you very much.
Thank you.
Interesting work. You can recognize expressions, mathematical expressions. It's look like maybe somebody have questions from present participants. No. What about language of presentation, representation of such expression after recognition? Different editors use different languages for formula representing. Which kind of language use your system?
Actually, on output on our system, our formulas are only in English language because maybe the main variables here in formulas are actually English. But you know, this is in prototype mode. Yes, we can go further and add more language when formula is recognized, and not only Latin symbols.
Understand, but I mean notation for writing formulas, for writing expressions, not language, speaking language.
Oh, I understand.
Natural
No,
language.
we don't. We don't.
Yeah, I understand.
We don't create this model
because where you should represent symbol of sum of or integrals or I don't know, logarithms. You should
understand. It's just prototype. Maybe when we go further, when we must more better classify it and be using notations and other things.
Okay, thank you.
Thank you for your question.
Now we ended all our list of reporters, and we are slowly going to closing ceremony. It is ordered to 6 o'clock. It's 7 o'clock Kyiv time. We have 10 minutes. Maybe stand by for 10 minutes because maybe somebody else will be connected to this end ceremony. I will not close the system, but we have break for 10 minutes to 7 o'clock p.m. according to Ukrainian time. Okay? Stay tuned and stand up. How it will be in English, not stand up. Дежурный режим. Вот. Pause. We almost ended our workshop. We are closing to the ceremony of closing, and maybe somebody else will be підключиться, connects to our last session. But not everybody understand that it should be on second link, not first but second. I have no access to link from Mikhail Emerich. That link was from his computer, and I cannot connect people from that link. And хто шукає, той знайде. Let me start our closing ceremony 1 minute before the time. I just call it to Vasil Litvin. He busy and cannot connect to us, but he sent us invitation with this event. And I also should express my gratitude to you for your participation in this machine learning data science workshop. And a few words formally, this workshop should be engaging and insightful event where we are delving into the latest trends, techniques, and applications in field of machine learning and data science. And your participation is crucial to the success of this workshop. And we are excited to have you join us in exploring the cutting-edge advancements in this rapidly evolving field. And together we try to learn, collaborate, and innovate to further our understanding and expertise in modern machine learning and data science. Generally, 46 reports we are listened. It was selected from more than 70 proposals. Some rejected submissions was rejected because of out of topic. Therefore, another maybe not so enough high level of reports. All these done reports will be organized into SEUR WS submission, and we hope it will be published under that publishing organization. I don't know. I want to listen maybe some your remarks you can say today to have some experience for next organizations. Maybe we should not divide our workshop into 2 sections, because it was demanded by SEUR VS to be mono topic workshop. They not allow to organize many topics in one conference, in one workshop. Therefore, next workshop will be, as I expect, only machine learning topic, or two different separate workshops, like it formally organized this way in last minute. Maybe have you any questions or proposals or thoughts about conference? No. Okay. We look forward to your future active involvement and contribution in our workshop, and very hope that all rulers of such CEUR WS journal will be fulfilled successfully, and we published our materials. Thank you for your participation.
Thank you.
Thank you for hosting the conference.
Thank you. Sorry, maybe not so very good organized, but we tried. Bye. Have a nice day.
The same, bye.